The most recent Olympics have just concluded. The local news has reported that the Arstotzkan Olympic team has won exactly 3 medals, but has not said which ones, of bronze, silver, or gold. Since we are unsure of the specific medal results, we can create a sample space to represent the possible numbers of bronze, silver, and gold medals that are won. So here we go. Here's our sample space. So this represents sort of 3 bronze, no silver, and no gold, whereas this is winning 1 bronze, 2 silvers, 0 golds. So we're sort of summarizing like that. So for example, here's 2 silver and 1 gold. Okay, so we understand the sample space and the associated sample points. What have we got? Let y be a random variable which counts the number of gold medals won by the Arstotzkan team. Determine the expected value of y if we assume that the probability of winning B bronzes, S silvers, and G golds is given by this formula here. 4 plus 2 times the number of bronzes minus the number of silvers won plus 5 times the number of golds, all over 100. Okay, so they're assigning probabilities, individual weights to these sample points here. Okay, and we're expected to figure out the expected value of y. Okay, so the first thing I'm going to do is I'm going to write down the sample points here, and I'm going to, let's see if I can keep them the same order. So start with gold and then work back. 0 silver, 1 gold. I'm going to assign them their probabilities based on this formula. Okay, 2 bronze, 1 silver, 0 gold. And 1 bronze, 0 silver, 2 gold. 1 bronze, 1 silver, 1 gold. 1 bronze, 2 silver, 0 gold. And then the ones where they got no bronze. Alright, there's all of them. Okay, so our formula says it's 4 plus twice the number of bronze minus the number of silver plus 5 times the number of gold, all over 100. So I can get 10 out of 100 here, or 1/10. I'm going to keep everything over 100 because I'm planning ahead. I've got to do an expected value computation, so I'm going to use a nice table. I'm going to have to add things up, and it would be really nice if, when adding things up, everything had a common denominator. So we'll use the 100 there. Okay, for the next one, we've got 2 bronzes. So 4 plus 2 times the bronzes minus the silvers plus 5 times the gold, so 5 times 1 here. And that's going to be 8 plus 5, 13. So 13 out of 100. Okay, let's get another color. 4 plus 2 times the number of bronze, so 4 plus 4 minus the number of silver, so minus 1, plus 5 times the number of golds. 5 times 0 is just 0. So we get 8 minus 1, that's 7 out of 100. Okay, 4 plus twice the number of bronze minus the number of silver plus 5 times 2, the number of gold. 4 and 2, so we get 16 out of 100 here. 4 plus twice the number of bronze minus the number of silver plus 5 times the number of gold. 6 minus 1 is 5 plus another 5, that's 10 out of 100. 4 plus twice the number of bronze minus the number of silver, which in this case is 2, plus 5 times 0. So just thinking about this, what does this mean? The probability that the Arstotzkan Olympic team had 1 bronze and 2 silver, that was their medal result. That's 4 out of 100, or 1/25. Okay. Then what do we got? 0 times, so 4 plus twice 0 is 0, minus 0 plus 5 times 3, 15. So 19 out of 100. So it seems very likely that they're going to get 3 golds. Good for them. Okay, and then 4 plus 0 minus 1 plus 5 times 2 is 10. So that's going to be 13 out of 100. 4 plus 0 minus 2 plus 5. That's going to be 7 out of 100. 4 plus 0 minus 3 plus 0, that's going to be 1 out of 100. So the least likely thing, if I'm following, is getting 3 silvers. It's more likely that they managed to get 3 bronze. But we're not here to make those sorts of comments or judgments. We're just working out the probability of each individual sample space so that now I can collect them and work out the probabilities that, what was it, y, right? That y is equal to 0 gold medals won, or y is equal to 1 gold medal. Because remember, y is counting the number of gold medals. And y doesn't care about how many silvers versus bronze or anything like that. So it's possible they got 0, 1, 2, or 3 gold medals. And now let's work out those probabilities. So we'll go back here and we'll say, well, which of these outcomes, which of these sample points have 0 gold, and then we'll add them all up. So 0, 0, 0, 0. I think that's it for 0 gold. So 10 hundredths plus 7 plus 4 plus 1. So 10 plus 7 plus 4 is 21, plus 1 is 22 hundredths. Which, again, we could simplify to 11 fiftieths, but I'm going to want that common denominator in a moment for the expected value calculation. Okay, now let's look for 1 gold. 1 gold, that's 2 gold. 1 gold, 1 gold. So 13 plus 10 plus 7 out of 100. 13 and 7 is 20, plus 10 is 30, so we get 30 out of 100. Okay, so 30 out of 100, 0.3 is the probability that the Arstotzkan team gets 1 gold, regardless of the bronzes and silvers. Okay, but still having a total of 3 medals. All right, let's use pink. Now 2 gold. There's only 2 of those. So I get 16 plus 13, so that's 29 out of 100. And we're almost there. We got 1 more to go. 3 gold, it's 19 out of 100. So while the most likely of the individual sample points was 0 bronze, 0 silver, and 3 gold, we can see that getting 3 gold without worrying about the silvers and bronzes is not the most likely thing. It's most likely that they'll get 1 gold medal here. Okay. But now, what do? We want the expected value. And so a great way to do this is just to make another column here. So 0 times 22 hundredths, I'll say that that's 0 hundredths. Again, keeping my eye on that common denominator because I know I'm going to have to add all these up, and that gives me the expected value of my random variable. 1 times 30 hundredths, well, that's just 30 hundredths. 2 times 29 is 58 hundredths. And then 3 times 19, 57 hundredths. Now we add them all up. So 0 plus 30 is 30, plus 58 is going to be 88, plus 57 is going to be, so 5, carry the 1, 145 out of 100. Now I could just write that as 1.45. That's the expected number of gold medals. Or if we wanted to, we could simplify, divide top and bottom by 5. We'll get 29 twentieths. So if I wanted it as a fraction, there we go. If I wanted it as a decimal, very nice, very, very good, there it is. And so that's the expected value of our random variable y, 29 twentieths.